This is tutorial 4A, the Laplace transform question 2. In this question, we are talking about the relationship between Laplace and Fourier. What is the integral transform got to do with Laplace? How to make Laplace become the Fourier? And let us plot the Laplace transform of a signal h of t that has this h of s representation, and what does it mean? Let's begin. The integral transform basically is a mapping. It changes a function. In our example, of course, our function is f of t into a representation via integration to something called f of s. Typically, the input signal has a small letter f, and the output signal has, or output representation has the capital version of the symbol. Small f become big F. T, which is the input domain, the input is in time and the output is in the complex plane S. Why we do that is because through the integration, some of the properties of the original function in time becomes more easily characterized and manipulated in the S domain. And generally, we can map back the original function by fs back to f of t. The famous integral transform is of course the Laplace transform as well as the Fourier transform. So this is the causal signal f of t, or maybe we are saying the unilateral Laplace transform of f of t into f of s. Unilateral because we are dealing only with the causal signal. In question 1, we saw that this is actually an inner product. So another explanation of this is simply we have measured f of t using different e minus st across all of s. And through this measurement, we produce something called the f of s, which represent f of t in the S domain. Now let us see the relationship between f of s and, well, let's try this, f of t. And you realize that both of them are integral transform. The top one is the Laplace and the bottom one is the Fourier. They all look very similar to each other. The only difference is that in the Laplace we have s, while in the Fourier we only have minus j omega. Remember that s is equals to sigma plus j omega, and therefore when sigma is equals to 0, actually the Laplace and the Fourier are identical. Hence the Fourier is a special case of the Laplace. So why do we have the sigma? In Brandon's lecture, he will show you that by multiplying with sigma, then more signal can converge. Basically, we are multiplying f of t with e minus sigma of t, allowing more signals to have convergence and therefore have the Laplace transform. Alright, let's see what is some of the references that may be useful to you include from Pratinical, from Stack Exchange, as well as this Claremont.edu talking about inner product discussion. So now let's continue with question 2b, how to make the Laplace transform become the Fourier transform. As I have mentioned, the Laplace transform is simply multiplying x of t with e minus j omega t. The difference is that compared to the Laplace transform, when we set sigma equals to 0, the Laplace transform is the Fourier transform. So for a detailed discussion, see Brandon's lecture here, as well as discussion in Stack Exchange. That's all we have for this question 2a and 2b. Thank you.